Proportions in triangles. Review. Similar polygons. Two polygons are similar if and only if their corresponding angles are congruent and the measures of their corresponding sides are proportional. So you have two similar triangles here. AB and DE is corresponding, same on the bottom. That is proportional to AC and DF and BC and EF. They need to have proportions in same scale factor. So this is how you write to prove that two triangles are similar, and this is called statement of proportionality. Also, the angles, corresponding angles, they need to be congruent. Let's review. We have two similar triangles. Here is the symbol for similar. AB is 15, AC is 20, BC is 25, and DF is 4. Find the perimeter of D, E, and F. So we need to find these two missing sides. How do we do that? We're going to use proportion. 20 to 4 is what is the ratio, the 20 to 4, 5 to 1 ratio. So write 20 to 4, that's the ratio from this triangle to this triangle. And then the perimeter of ABC is 15 plus 20 plus 25, which is 60. So perimeter is 60 here, and we don't know the perimeter of this one. So that's going to be your X. So proportion, the perimeter is going to also have proportion. The perimeter of two similar triangles are proportional too. So 20 to 4, 60 to X. Let's cross multiply and divide. The perimeter of this one is 12. So we're going to look at a side splitter theorem. If a line is parallel, please circle the word parallel, to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. The converse is also true. Take a look at these two triangles. You have a triangle here, and if you have 1, 2, this line is parallel to this line. So this triangle, the bottom, one side, is parallel to this big triangle, the bottom. They're parallel to each other. Then, if it does that, then it splits this. That's why it's splitter theorem. Then the two sides, it divides these two here proportionally. So BD right here is parallel to AE right here. If then C and B and BA, they're going to be proportional. CD is proportional to DE. So they're going to have same proportion here. This is called splitter theorem because these two parallel lines split and make these sides proportional to one another. So if this is 10 and this is 5, then this is going to be 4 and 2. So 2 to 1, 2 to 1 ratio. So let's look at some examples using splitter theorem. Given E and D is parallel to A and C, so right here is parallel to here in this triangle. And then B is 6, EA is 4, BD is 9, then what's X? So you use proportion to find the missing side. 9 over X is 6 over 4. Just go 9 to X, 6 to 4. Set up proportion. 9 times 4 is 36. Divided by 6, X equals 6. You can also come up with another proportion. 10 to 6, 9 plus x to 9. So this side, the whole thing to this, whole thing to that. You can do that also. So x equals 6. Let's take a look at the triangle here. ED is parallel to AC. We're going to solve for x. So we're going to write BE 2x plus 3 is over 5 because it's they're proportional here. And then 4x plus 3 over 9. So this side, left side is here. Right side is here. And then what you're going to do is we're going to cross, multiply, and solve for x. So 9 times 2x is 18x. 9 times 3 is 27. 5 times 4x is 20x. 5 times 3 is 15. Put the equal sign. Subtract, and divide. You should get 6. So 6 is the answer. Corollary to the side splitter theorem. If 3 or more parallel lines intersect two transversals, they cut off the transversals proportionally. So if you have 1, 2, 3 parallel lines, 3 or more, and then you have two transversal like this, then they cut off the transversals proportionally. So here you have AB is proportion to BC. AC is proportion to DF. And then BC, EF, AC, BC, DF, EF. So basically this side, the top and the bottom, they're proportional. So if you have 3 or more parallel lines intersect two transversal, this top side, this side, proportion, this side, proportion, the whole thing on the top, whole thing on the bottom, they're proportional. So let's look at an example. What is the length of side A along the river? We can use proportion. 9 to x, 7.2 to 8. See these 3 parallel and 4 parallel lines, and you have a transversal like that. So this 9 and these are corresponding. These are corresponding. You can set up to be proportional. So 9 over x equals 2.8 over 8. So you can cross, multiply, and divide, and x equals 10. You can write x over 9 equals 8 over 7/2. It's gonna give you same answer, 10. So this one is x equals 10. If I want to find this side C right here on the bottom, let's say that's a y, then we can also do 6.4 over 8, y over 7.2, or you can do 8 over 7.2 equals 6.4 over y. They're proportional to each other. So they're corresponding like that. Anyways, this right here answer is 10. Triangle angle bisector theorem. An angle bisector in a triangle separates the opposite side into segments that they have the same ratio as the other two sides. So take a look at this triangle. If CD is a bisector of ACB, then AD to DB, their proportion, is going to be equal to AC 2 over BC right here. So right here, AD over DB, this is corresponding bottom, is going to be same proportion to the side, AC and BC here. So these two are proportional. So if it's bisecting, if it's equal here. So this is called triangle angle bisector theorem. If an angle bisector in a triangle separates the opposite side into two segments that have the same ratio as other two sides. So let's take a look at an example here. Solve for x here. So we're going to use proportion again. 18 over x, 10 over 12. So 18 over x, this is the side, and this triangle is 10 over x. So 10 over 12. So 18 over x, 10 over 12, and you can set up that way. Or you can do 12 over 10, x over 18, it doesn't matter. Or you can do 10 over 18, 12 over x. It doesn't matter how you set up, as long as you are putting the right corresponding spot, you're going to get the same answer. So I'm going to stick with 18 over x, 10 over 12. Cross, multiply, divide. X is 21.6. So this is 21.6. So you use proportion to solve the missing side.